Hi, I'm Lee, and this is NASA Now, excavating the red planet. What are scientists looking for on Mars? And it's the size of a Mini Cooper. We'll show you NASA's next Mars rover. That's ahead. First, here's what's happening at NASA now. NASA's next Mars rover is nearing completion. The rover is called Curiosity and is the size of a Mini Cooper. The spacecraft will be shipped to NASA Kennedy Space Center in Florida this month, where preparations will continue for launch between November 25th and December 18th of this year. Among other things, Curiosity will study microbial life and will be used for preserving evidence about whether Martian life has ever existed. And NASA's Mars Reconnaissance Orbiter uncovers big changes in the red planet's atmosphere. Check this out. The Reconnaissance Orbiter has discovered the total amount of atmosphere on Mars changes dramatically as the tilt of the planet's axis varies. This process can affect the stability of liquid water if it exists on the Martian surface and increase the frequency and severity of Martian dust storms. Now let's take a look at the past.
November 1964. Mariner 3 is headed to Mars but loses contact after takeoff. Mariner 4 launches 3 weeks later and in July of 1965 becomes the world's first spacecraft to take close-up pictures of Mars, returning 21 photographs.
We all know water is vital for our survival here on Earth and in space. NASA is investigating techniques for extracting water from soils for future Mars explorers. Here with details is Dr. Kurt Sacksteder from the Space Environment and Experiments branch at NASAâs Glenn Research Center in Cleveland, Ohio.
I'm Kurt Sacksteder. I'm the chief of the Space Environments and Experiments branch at the NASAâs Glenn Research Center in Cleveland, Ohio. We're here in the SLOPE facility, which is a facility that was built to simulate the surface conditions on planets like the Moon or on Mars. We prepare the soil to match the properties that the Apollo astronauts measured when they were on the surface of the Moon. We take the source containers, we lift them up, put them on top of this device, and then measured quantities of material can flow down into a container that we take over to the soil bin and put it in place for testing. What we're doing now is to try to develop excavation devices that would allow us to collect sufficient quantities of soil on the Moon or Mars that we could then transfer that material into some kind of a processing plant to extract important resources like water. Water is probably the most important resource to be able to find away from Earth, because with that, we can not only, of course, have water that the crew can drink, but we can take the water apart, giving us oxygen for the crew to breathe, but taking the water apart also gives us hydrogen, which we can use as a propellant. In addition, especially when we go to Mars, where the atmosphere has carbon dioxide in it, if we collect the carbon dioxide and we collect the water, we can make hydrocarbons ranging from methane all the way to rocket fuels. And so it makes more and more sense to develop technologies that would allow us to use that water to keep the crew going for extended periods of time. There have been measurements made from orbit around the Moon, and an impact device called LCROSS was able to detect very substantial quantities of water that is buried probably just below the surface of the soil on the Moon. And these measurements have not been verified by devices that are actually on the surface of the Moon. And that's really the next step, is to do what we call ground truthing those measurements made from orbit. So we're primarily interested in three types of tools that you would describe as excavation. The first is what we call a coring drill that allows us to pull up small samples from below the surface. to measure what's actually there and tell us, that we're in the right place to actually do some more serious digging. The next thing that we may want to do is to actually have what you would think of as a shovel that would allow us to dig, pick up material, and then dump it into some kind of a collection hopper. The third type of device that we're interested in being able to use on a planetary surface is something that looks pretty much like a bulldozer blade, so that we can actually contour the surface to make things like roads, possibly landing pads for later rockets to land and take off, and places where we could place a habitat system. So we could use the moon as a resource stop to prepare us to go elsewhere in the solar system.
Did you know that Mars has 2 moons, and one of them, Phobos, orbits dangerously close to the planet's atmosphere? Someday the gravitational pull will smash the moon to bits, and the debris will stay in Mars' orbit, making a ring like the rings of Saturn. Scientists predict this will happen in the next 50 million years.
Now it's time to check out what's up.
Next time you look up with your binoculars to see Mars, you may wonder why the planet is red. Well, the red color is caused by oxidation of the iron-rich materials on the planet's surface. You might say Mars is covered with rust.
Teachers, here's a great resource to give your students the tools they need for lunar exploration.
Check out the Lunar Nautics content modules here on the virtual campus, Designing a Mission to Live and Work on the Moon. These lessons focus on real-world understanding of Newton's laws, along with human presence on the moon and future exploration.
Well, that's it for NASA Now. Be sure to tune in next week when we learn about total lunar eclipses. We'll see you then on NASA Now.
NASA Now comes to you from the virtual campus at NASA Explorer Schools.